Hello, Algebra students, and welcome to our last lesson of this unit. So we are doing lesson 1.8, which your objective is I can graph functions from ordered pairs. So part of this lesson was understanding reviewing kind of your ordered pairs and knowing your quadrants of your coordinate grids. But we are just going to quickly review that. We're not even going to go over some examples because instead you had that N1 topic on IXL that you needed to get done. So then we're going to go through two examples on graphing stuff. So actually using equations and graphing them on a table or on a coordinate grid. So just kind of as a review as we're going through here. So remembering that the coordinate plane is formed with the intersection of two parallel numbers. Remember, you've got your axes and your origin. Your origin is right in the middle of the two lines. This is your y-axis. This is your x-axis. Okay. We also have quadrants. They start and they go counterclockwise. So this is quadrant 1, 2, 3, and then 4. And remember, your ordered pairs are always written. So it says an ordered pair consists of an x-coordinate and a y-coordinate. And it is written as x, y. Points are named with capital letters. So if they were to actually give you like, hey, point C is where is point C? It's going to be with a capital letter. One thing just real quickly you want to go through then is those points. So maybe you came up with a coordinate point of 1, 2. Well, 1 is in the x spot, so that means it's going to be 1 to the right on the x spot. And then it's going to be 2 up. 1, 2. And here's my actual spot. So right there, I was just kind of showing how far over it was. But that should be fairly much a review so that we can get into talking about your actual graphing some graphs and not just putting dots on graphs. So here is the big part we need to know. It says an equation that contains two variables can be used as a rule to generate ordered pairs. When you substitute the value x, you generate a value for y. The value substitute for x is called the input, and the value generated for y is called the output. In a function, the value y, the output, is determined by the value x, the input. All the equations in this lesson represent functions. So the biggest thing was when we're graphing, one of the main ways to graph a function is by setting up a table and setting up input and output tables. And so understanding that you can put anything in for x, but then you want to know what your output is. Okay, again, your x and your y, remember they're going to make a coordinate point then. So maybe you threw in 1 for x. Let's just say, okay, well, 10 times 1 is 10 plus 5 is 15, so y would equal 15. So now I have a coordinate point of 1, 15. Okay? Let's keep going. Alrighty. Let's look at this first application here. So in example 1, it says art application. A caricature artist, so those guys who create the like super funny cartoon versions of you, charges his clients a $5 setup fee plus $10 for every person in the picture. Write a rule for the artist's fee. Write ordered pairs for the artist's fee when there are 1, 2, 3, and 4 people in the picture. All we're doing is coming up with an equation or writing a rule. So let's think about our power math again. This is something I want to be practicing with you. So P is your problem. So you look and you find the actual problem within here because word problems are very messy. So the actual problem or direction is write a rule for, I can't draw straight, artist's fee. And then also write an ordered pairs. So that is also part of your rule, okay? Always then your operations. So thinking maybe you need to circle some of your operations. So something that I think would be important, charges his clients a $3 setup fee plus $10 for every person in the picture. This definitely tells me for every person, this is going to show me a multiplication problem, okay? Words, so any words that are important, so your numbers, usually these kind of things, okay? Plus this fee, so that also is a setup fee plus this. That's also an operation. I caught that one late. And then we also want to know that 1, 2, 3, and 4 people in the picture. Alrighty, so we're going to create an equation, and we're going to write it in my favorite form, and I hope you all know it, y equals mx plus b, okay? So remember that x is your input, your y is your output, okay? So let's look at this. So I like to start with the thing that's being multiplied, because I said it's being multiplied, okay? So it's $10 for every person. So maybe actually I put in 10p, but we're going to put it 10x, because it costs $10 per person. So if me and my best friend decide to go get a caricature, it's $10 per person in the picture, plus this additional fee of $5. Okay, you could have written as 5 plus 10x. That would have been the same. That's fine. And then I'm just going to set it with y. Okay, and that's all I did. I just come up with an equation. I'm also going to set it equal to y. That's just going to show me my output. Okay, so then what I'm going to do is so we did a rule. We wrote the rule. That's what we did. We wrote the rule for the artist fee. The rule is this. Y equals 10x plus 5. $10 for each person, depends on how many people there are, plus that additional $5 fee. So we need to come up with the ordered pairs for how much is it going to cost for 1 person, 2 people, 3 people, and 4 people. So I'm actually going to set this up as a table. I think it's just going to help you a little bit more. So these are the amount of people, or my x. And y would be money, or my output. Money it's going to cost. So we needed to figure out for 1 person, 2 people, 3 people, and 4 people. So what I'm going to do is I'm going to plug in that x in this equation. So I'd have 10 times 1 plus 5. Well, 10 times 1 is 10, plus 5 is 15. So for 1 person, it's going to cost $15. If I wanted to figure out for 2, again, I just plug it in that equation. That's going to cost $25. I bet you can already see what the pattern's going to be. For 3 people, it's going to be $35. 10, 15, 25, 35. I bet that one's going to be 45. Let's see. Oops, forgot my parentheses. Yes, that will also be 45. Okay, so that's what is generating that. Now the biggest part then is coming up with those ordered pairs. So remember your ordered pairs are written as x, y. So in this case, for 1 person, it would be $15. All right, another ordered pair would be 2 people and $25. 3 people and $35. And so on. You can continue writing. Just for the sake of time, we're going to continue on. But that's something that's being really important as we move into our other problems here. Alrighty, so these ones are the ones we're going to have a chance to actually graph. So just give me a minute. I want to make sure I've got black right now. Alrighty, so we are going to generate the graphing ordered pairs. So generate ordered pairs. So again, that's going to be your x and y for each function using the given values for x. Graph the ordered pair and describe the pattern. All right, so we're going to set up a table just like we did before so that we can solve this out, okay? So here's what I'm going to do. I'm going to make this a little bit of a different table. I'm going to add an extra step in here. This is going to be my x values. This is going to be my y, and here will be your ordered pair, x, y. All right. So I'm going to plug in. So they say they want me to solve this graph for x is -1, x is 0, x is 1, and x is 2. So I'm going to plug it into this equation right here. So I'd have 4 times negative 1 minus 3. That will give me what y is. So 4 times negative 1, okay, negative 4 minus 3, negative 7. So now I have negative 1 and negative 7. And that's my ordered pair. And I could already go over here and plot that on, which is down here. Okay. Plugging for 0, okay, 4 times 0 is 0. Minus 3, so it's going to be a negative 3. So now I have the pair, ordered pair 0, negative 3. 0, negative 3. Alrighty, so jumped a little bit ahead just to save for the sake of time. So plotting near 0, negative 3, I went in and filled in 1 as well as 2 and continued to solve out. Once I have that then, so putting your dots on here, and then the big part is connecting your dots all the way through. So making sure to have some arrows at the end also will be important. Now, it should look a little straighter than this. It's kind of hard for me to write on the computer though. So here you can see the work and make sure you're kind of following along correctly. And let's go on to the next one. And I kind of started setting it up. So you're going to have to give me just a second to double check this. I think it will still have the writing. Yep, all right. So this is another problem. And this time, though, you have y equals 2x squared, okay? So it is to the power of 2. And so they want us to solve it for negative 2, negative 1, 0, 1, and 2. And so plugging that in that equation, and that's all I've done so far is setting it up, okay? And then we can go and find our ordered pairs. So I'm going to first start by thinking, okay, 2 times... But first, I've got negative 2 squared. Negative 2 squared, remember that ends up being positive, so it's a positive 4. So really you have 2 times 4, which is 8. So I'd have an ordered pair of negative 2, 8. So negative 2, 8. This could be a little bit off my grid, but that's okay for now. If I have negative 1 squared, that's still going to be 1. So 1 times 2 is 2. So I'm going to have negative 1, 2. All right, 0, I have an x of 0. Well, 0 squared is 0 times 2 is 0, so it's now at the origin. Oops, forgot to add it over here. All right, I'm just going to finish this one out. So what ends up happening with this graph is we do actually get a curve. So it comes down and makes like a really tight little U here. Boop, as best as I can. There's still arrows at the top, okay? So solving out with my ordered pairs, again, I just went through and plugged in x, found my y, make my coordinate points. We have one more to get through. Let's see if we can get through it very quickly. Alrighty, so our last one, the graph. This time we have absolute values. Oh, so again, just set up your tables. So I'm going to set it up and then we'll go through it. Coming on back, all I did was set up with my x's. So they want negative 5, negative 4, negative 3, negative 2, negative 1. And then I just threw them in this equation part. So it's x plus 3 with the absolute values. So we need to take the absolute value. So I want to think first, okay, negative 5 plus 3. Well, that's a negative 2 with an absolute value. So that means then it's going to end up being a positive 2. So I have the coordinate point, negative 5, 2. Again, I'm getting that negative 5 from the x over here. So if I want to plug in negative 5, 2, there's my dot. All right, next one. Negative 4 plus 3, well, that's going to be a negative 1, but that is a 1 once it comes out of the absolute value, so then I'd have negative 4, 1. Negative 4, 1. Okay, I'm going to try and go through these fairly fast here, so just give me a second. Oops, I accidentally put in 1 here. Finishing off this graph, you end up having this one's actually more of a V, so it's straight. And again, I can't get through the lines very well. Whereas when you have those exponents, it was more of a U. This is more of a V, okay? Make sure to watch out